So now that I get the tree imported into Unity, I want to demonstrate how the LOD system benefits us and why it's worth the extra time to create LODs in Blender and set up the LOD group in Unity. So I've taken the tree and more or less created a grid of trees. So we have lots of trees in the scene. And if we go over to our game window and push play, we'll get an update of our vertice count. And you can see right now we're already at almost 500,000 vertices. That's quite a few. Computer should not struggle to render that at all. I've easily had 10 or 15 million vertices on the screen. The computer runs just fine. But this isn't something we want to do. We don't want to continue this pattern, especially if we're going to create a large terrain. We want our computer to run as fast as possible. That gives us some more overhead for AI or some fancier kind of effects and visuals. So we want to be able to knock down the number of polygons that we are having to draw. And so let's just keep that number in mind of 416,000. That's what we're drawing right now. So we want to create a lower poly model of our tree, and we're going to have to do that in Blender. So I'm now back in Blender, and this is the tree I created in an earlier tutorial. What we want to do is create a lower polygon count tree, and with a low poly model, we can do this with a Decimate modifier. If you have a more realistic model, you're going to want to use more sophisticated techniques. So to do this, I'm going to duplicate the tree. So I'm going to hit Shift-D, slide it over on the X-axis, and then I'm going to add a Decimate modifier. And this ratio here is what I'm going to adjust. So I'm going to slide that down. Usually get it down to about a third. And you can see it's getting rid of faces. Here's our face count. We've lost over 1,000 faces so far. And with a tree like this, because these meshes are going to get swapped out by the LOD component, I'm trying to make sure that the shape stays more or less the same. That while my leaves might be losing some faces, they're still kind of the same general shape. And that looks pretty good to me. Now, because these are going to be getting swapped out by Unity, we don't want our tree jumping back and forth from left to right, so we need to put them on top of each other. So I'm going to open up my side panel, and I'm going to knock the location back to 0, 0, 0, and the two trees are on top of each other. The next thing we need to do is, just for simplicity and ease once we get into Unity, is rename these models. So I'm going to click on the original tree here in my hierarchy, icosphere, and I'm going to click on this box. I kind of think of it as the object tab. And I'm going to rename this as LOD 0. Click on the other icosphere, and I'm going to name this LOD 1. So I'm back here in Unity, and I've done a few things. I've imported that FBX file with the LOD levels as children, and the parent is an empty game object. I've dropped that into my scene and created a prefab, and I've named that LOD prefab. Not very creative, but there it is. And then I've replaced the grid of trees that I had earlier with a grid of this new prefab. If I push play, you can see that the vertice count is higher than it was before. We were at 416,000. Now we're at almost 480,000. And the reason that is because each of our trees has two models and the computer's having to do essentially double duty. Not quite double duty, but close. So what we want to add is an LOD group component to our prefab. So I'm going to select the first prefab here. If I open that up, you can see the LOD levels there. On this empty parent, I'm going to add an LOD group. So hit add component and search for LOD group. Now I only have two LODs. So I'm going to left click on this third level here, right click, and choose delete. If you want more LOD levels, you can use as many levels as you want. I found for my purposes that 2 levels for trees works pretty well. Next thing we need to do is assign the mesh to each of these levels. So I'm going to click on LOD 0, and I'm going to drag that mesh from the hierarchy down into the renderers. I'm going to click on LOD 1 and drag LOD 1 into that level. Now, if I move my camera back and forth, you can see that it's switching those models out. And if I go into this cold region, it won't draw the tree at all, which is super useful if you have a large forest and you're not going to be able to see it. Unity will automatically cull it and not draw it. There's a small overhead for using an LOD group, but it is generally a benefit and your scene will run faster. Now these thresholds of where it switches between LOD levels, you can simply drag and change. And you're just gonna have to play around with that depending on your scene, when it's okay for a tree to pop out or pop into your scene, and when does it switch models. And you wanna do that just so the player's not necessarily seeing it or it's super obvious. I find that I usually have to do LOD, the LOD 0 quite a ways away, and the cold can get pretty far out, maybe something like that. Okay, now since it's a prefab, I'm gonna hit apply, and that's gonna make that addition to all the other prefabs. And you notice that they're cold, but if I zoom in, they all reappear. And that's what's gonna happen in game mode. So let's push play and see what we have. Notice here, our vertice count has dropped a little bit. It's dropped down to 300,000. Okay, so before we implemented the LED, it was a little over 400,000. And we can continue to play with that by adjusting our LOD level. So if I bring this back up, hit apply, go back to play, our vertice count is now down to 130,000. That's roughly a third of what we had without the LOD system. So there you go, we've implemented an LOD component on our low poly tree. We've cut our vertice count down from a little over 400,000 to a little over 100,000. Our total vertice count is about a third of what it was when we started. And with a little bit of tweaking, your player's never gonna notice. So I hope that was helpful. Thanks for joining, and I'll see you next time.